Have you guys been in AP classroom much? Like in other classes, other AP classes?
I think I've only been in AP classroom twice, and you always want to get access to go over these.
Really? Any of you girls? Same deal? Sweet. So AP classroom, can you log in? I used to use my personal email, and that's how I got all my information from my other school to this one. Can't do that anymore. AP Classroom. This is what I get. AP. Gosh. Don't care. Have you guys used Desmos much as an online calculator? They offer in the AP exam the use of that program. I think they've got it kind of built in. Here are practice exams, that's a thing. The review. Oh, God, what is your thing? I don't care. These review sessions are pretty good to look at if you're feeling some stress about it. They've got some of the best AP teachers in the nation do tutorials. They did them since COVID, so 2021, 2022, 2023, and 2024. We did a lot of them with the BC class, but this class was still learning stuff, so we couldn't use it. But those are available to you. I'm going to assign all of them. Not that you have to do them, but I just want them available to you. So these are last year's review. And then I'll do 2023's as well. If you want the other 2 years, 2 years, I can get those to you as well. But I'm just offering those to you. They're videos. You can watch them at 1.5 speed and pause if you want to pause to try the problems. You might be able to do most of them because I think you're pretty well prepared at this moment. I think we just need more practice with multiple choice. And you guys will be in really good shape. We're still good with Good Friday at 8 a.m. All right, 8 a.m. These units are good. I usually start with Unit 3. And I'm going to assign the multiple choice questions to you guys. I'm going to allow calculator as well, in case you want to try the online calculator. So that's Unit 3. We'll do all the units. I'll put that down as the thing that I'm assigning today. Do you guys see that it's available?
Yeah.
Multiple choice questions. If you want the free response questions also, let me know and I'll make those available as well. I think we're going to do, let's see what I did last year. 3, 4, 5 in 2 days. 6A, 7A, 8A. So we'll do all of them. I'll just make them all available to you now. And then when I assign them, I kind of expect them to be done the next time we have class. And when class starts, I'll grab those scores that you got out of them. come to class with questions, I'll answer them. But that will involve you communicating with me. I know that might be tricky. A little joke. It's a little joke. Okay, so I'll do that right now. Nothing. That's 3. Here's 4. Unit 5. Let's view all. Did I already submit to you?
She said for Monday, unit 3.
So one person did this. Did I already talk to you about it?
No.
Will started it.
No.
Did you just start it like a minute ago?
No. Unit 3.
5. Part A.
So like on 220, 1150,
Did I assign it at some point? I may have.
Oh, I think you showed us this once, but I don't think we did. You showed it to us and wanted to do it for review.
These multiple choice questions, ask them, they're kind of funky, but like most of them you've done things just like it and won't be too difficult for you. But some of them are questioned in a weird way and will help you to go through these practices, exams. So I gave you the review. I haven't released the practice exams. I'm not sure how these work. I think 17 is the actual one that I used before. Gosh, should I try to use it on? It's so nice to take a paper exam for math class. But you probably need practice doing it on your iPad. I don't know how that is monitored. Like, I can't block other websites. Not that I distrust you, but I have taught for 32 years, and I've had people who I thought I could trust break my confidence and my heart. So, the temptation is real.
Is this the first time?
Is what the first time?
But was last year on paper? Or was that not that?
Last year was on paper. Easy. This year, multiple choice would be on your screen. And I don't know how Mrs. Rodriguez is going to do that.
I think they can lock your browser so you run the same tab. Can you read it?
Yeah? Good. Not for me to worry about. But maybe I'll find an exam that we can go through in class, release the questions, and we'll practice doing the multiple choice part. We'll have to take a class to do that. Everybody good? I assigned a bunch of stuff. Hopefully that's not stressful. What did I say? 3?
For example, yeah.
Multiple choice questions? What do they look like? There's 18 of them. Let's do some now. If they don't match, tell me I got
change.
Probably maybe last year.
It's changing the application. I come in up with those 2 days after the change.
Is this the first one? GVAX equals natural vax. People, I'm asking you a question. Look at the board, look at your thing. Is this the first one?
Oh, yeah.
Thank you. Take 30 seconds and try to do it, and then we'll talk about it. Or do you need 30 seconds? Thanks, Johanna. Thank you. You guys have this? So we want to take the derivative of GVAX, but we know GVAX. So f of GVAX is f of the natural log of x. So the derivative is thanks. You good? Hmm. Oh. Yeah, I understand. So we want to take the derivative of this, and the derivative of a function inside of a function, you take the derivative of the outside function, leave what's inside alone, and multiply that by the derivative of what's inside. So it looks like it's d. Does that make sense? Is this the second one?
Yeah.
Yes.
All right, that's 30 seconds. What do you think? Is one, first option, the chain rule problem? You can say yes or no out loud.
No.
It's a chain rule question.
Yeah.
You know what a chain rule is? It's when you have a composite function. You take the derivative of the outside. Like if you're taking the derivative of this, it's cosine, leave what's inside the same, and you multiply that by the derivative of what's inside. Like that's the chain rule. Would you use the chain rule for 2? No, you're correct. You would use the product rule, not the chain rule. Like the first times the derivative of the second, plus the second times the derivative of the first, not the chain rule. How about 3? Yeah, you could kind of use the quotient rule, but if I were doing 3, I would rewrite it as and use the chain rule. So it's -1 times that to the power of -2 times the derivative of that. Right? So you weren't wrong by saying no, but yeah, it's probably the most appropriate way.
D.
I would say it's D. If I were doing the spelling, I would say D. Does it give you the answers right away? You have to submit and then it gives you the answers.
Yeah, just a minute.
It's
Alright, bummer.
you can go back.
We good? Questions with that? Okay. multiple choice part without a calculator, and this looks like it's no calculator, you get 2 minutes per problem. And I'm giving you 30 seconds per problem. Do you have an answer? D? Yeah, that's right. Because the derivative is 2 times this to the 1 power times the derivative of what's inside. So that would be f prime of 3x. And then when you take the derivative of that, you have to multiply by 3, the derivative of what's inside that. So it is d. Does that make sense? How about this? We want an implicit differentiation. We want the slope of the tangent line at 1, 2. So you're taking the derivative in terms of x. So every time you take the derivative of something with a y, you have to multiply it by dy dx, or y prime. Two. There's 2. Oh, minus 4. I must have something. And the bottom. That's not so bad. 4 minus 3 is 1. 1a, b. So you get b? Good. The derivative of y to the third is 3 y squared y prime. Derivative of this, you have to use the product rule. And if it's a free response, showing that you're using the product rule is usually worth a point. If you have to do implicit differentiation and it's free response. Right? It's the first, negative x times the derivative of the second, 2y prime. Plus, it's derivative of the first, which is negative 1. Times the second y prime. And then the derivative of y to the third is 3, I'm sorry, x to the third is 3x squared. Derivative of 5 is 0. That's a mistake many people make, is put 5 there. Right? And then we solve for y prime and plug the point 1, 2 in. Pretty good? This is also a implicit and implicit differentiation. Sophie, is that what you got? Do you see where? I'm not sure I made this up. Derivative of sine of something is cosine of something times the derivative of what's inside. That equals the derivative of the right side, which is 3 minus 2y prime. The hardest part, I think, the trickiest part is when you distribute this whole thing to the 1 and the y prime, you get this times 1 plus this times y prime, right? And then get all the y prime terms to one side, and then skip the steps. So y prime terms to one side, that's y prime cosine of x plus y plus 2y prime. And everything that doesn't have y prime to the other side, 3 plus minus. Cosine of x plus y. Okay? And then factor out the y prime and divide that away. And I got d. Did you guys get d? Yeah.
I don't know.
Do you understand how to do it?
Yeah.
I assume this is the next one? Selected values of f, f prime, g, d prime, are given in the table above. Oh! Gosh. Y dx at the point, okay. All right, who the heck cares? I'm assuming dy dx. So we can take the derivative of this. And see what happens. I don't know. I don't know. First times the derivative of the second plus the second times the derivative of the first equals negative 1 minus y prime. What are we doing? Solving for y prime? Yeah, we could probably do that. Gosh, cool. So y prime we can put with this term. Cruel. I don't think that's wrong. Factor out y prime. Plus 1. which is dy dx, that's what we're looking for, right? So let's just do this at the point -2. So y prime at this point is -1 minus some number. It's g of 4, g of 4 times f prime of 4 over f of 4 g prime of, oh, dang, screw this up. Because x's are not the same as y's. Y's 4, okay, so that's plus. Okay. X's are 2, negative 2's. Okay. Do you have these numbers? You're gonna tell them to me?
It's, G of 4 is 5.
G of 4 is 5.
F prime negative 2 is 4.
So on the top we have -21.
Yeah.
God, they hate me. And on the bottom, what's f of -2
3.
3,
times g prime of 4?
2.
6 plus 1, 7. -21 over 7, so it's -3. Son of a gun. Why would they do that? Why do they do that to me? Like, I'm the guy who misses negative signs and throws things in. Now this, there's no way in a million years that we'd ever give you something stupid like this on a multiple choice, because it takes too long. However, in a free response, there could be something weird like this that you would have to take the derivative of in terms of x, because we're trying to find y dy dx. And you would have to be able to do that. But there's no way there's a multiple choice question like this. I couldn't imagine. Anyway, that was fun, right?
No.
I'm glad I was there to
That's
do
more
this.
than that.
Oh, when I see a question like this, right? So here's the function, and here's an estimation for the function using a line. Would the estimation be an overestimation or an underestimation, and why?
Underestimation.
It's a what? Why?
So the line is below the.
Good. You could just say because f double prime is positive, that means it's concave up, which means the tangent line would be an underestimation. But good, right? Perfect. But that's how to say it in calculus. Second derivative, the graph of the decreasing differentiable function f is shown above, also shown as a line tangent. Let g be the inverse of f. Which of the following statements is true about g prime? So this is what I understand. We've got two functions, f and g, and their inverses. F has the point 4, 6. And so g has the corresponding point 6, 4. And my dyslexic brain, I just wish. The slope of the tangent line, so the slope of the tangent line at this point, so f prime of 4 is -3/4. That means the slope of the corresponding point, that would be a g, g prime of 6 is what?
Negative 4 over 3.
And I didn't read the choices, but I'm assuming that's what it is. Anyways. Yeah. So it's 0. Does that make sense? They tell you F has an inverse named G. And the way you find inverses is you just take all the points on F and just switch them all. And they give you this specific point. So I knew it was one of these weird, find the slope on F and take the reciprocal for its inverse, and that'll be the answer. I didn't read the problem, I just looked at it. And, you know, my first thought is that tangent line an overestimation or underestimation. But then, you know, this is another application for this. Any questions about it?
Yeah.
Okay.
How'd you find the first slope? -3
The slope of this, I just look for 2 points that I can find the slope between. And then I rise over around it. Down 3, over 4. Maybe 3/4. Good? That's it, that's the concept. Probably the next problem is a similar situation. Oh yeah, same deal. If G is the inverse of F, so I always organize my brain like this. I have F with the point in F, G corresponding point in G. Find the slope in terms of X, you know, at the X value for F. And I can find G prime of -2 by finding F prime of -1. G prime of 2 by finding the reciprocal of F prime of 1, negative. F prime of -1 is 3 minus 4 plus 4 is 3.
It's +5.
Did I miss something?
It's
Plus 5, not 4.
No.
Oh no, the derivative is plus 4.
+5. Oh,
Right? Thank you. Should always be checking that one. What the heck is this? Yeah, it's B. No, it's A. No, it's B. One over F prime of -1. 1/3 is what G prime of 2 is. Do you guys get the concept? Do you remember learning it? Table of above selects the values for differentiable and decreasing function f and its derivative. G is the inverse of f. Okay. That's the way my brain works. G prime of 2 this is 2, 5, so this is 5, 2. So this is f prime of 5 is that. Yes.
Wouldn't it be C because it's looking for G out of 2 certain so it's F?
Oh, so we're looking, you're exactly right. Thank you, Denise. So we're looking for g prime of 2. So we're looking for the point where g's x coordinate is 2. That's where f y coordinate is 2. Yeah, that's perfect. Thank you. I see it does help, but I was looking at the answers instead of looking at the question. So yeah, g prime of 2, we need the x, the y coordinate that goes with this one. So this is the point for x for 2. And then g we have 0.25.